We're being asked to find the cosine of an angle when all we know about that angle is what the sine is, and the sine is -1/2. So one of the things that's going to help me out is using what I know about sine, and that the sine of any angle on a unit circle is related or can be found by looking at the y-coordinate. So we're looking for an angle that has a y-coordinate of -1/2, where that angle intersects the circumference of our unit circle. So since it's negative, it has to be underneath the x-axis, and there are in fact going to be two angles that have a y-coordinate of -1/2. But if we're going to find the cosine, we need to find the x-coordinate, because we know that a cosine, right, we know that's related to the x-coordinate, or the base of the triangle that's formed. Well, using what I know about special right triangles, I actually know that this angle here, our reference angle, needs to be 30 degrees, right? We're 30 degrees underneath the x-axis, and 30 degrees, or pi/12 radians. And I know this because a 30, 60, 90 right triangle with a hypotenuse of 1, and our unit circle has a hypotenuse of 1, the shorter leg is 1/2. And so that's going to get me 1/2 below the x-axis. The other thing that we know is that the longer leg is √3/2. So that lets me know that, in fact, the x-coordinate of this point here is √3/2, because that has to be that distance of the longer leg along our 30, 60, 90 right triangle. And this one's going to have an x-coordinate of -√3/2, because that's how far we have to go in the negative direction for this particular triangle. Well, cosine is exactly that x-coordinate. So I have two cosine values, right? Cosine of that angle, and let's just call it cosine theta in this particular case, is going to be either -√3/2 or +√3/2. And in our explanation, we would want to be sure that we used what we know about 30, 60, 90 right triangles, and what we know about sine and cosine, right, those coordinates on that unit circle.